All right, welcome back to the Developer Week main stage. Up next, we are excited to welcome Daniel Graves, Chief Technology Officer at Delphix. Daniel, please join us on screen.
Hi there. Good morning. Thanks for having me.
Morning and welcome.
Okay, so as he said, my name is Dan Graves, and I am the CTO at Delphix. I've been in tech my whole career, working at Apple, Sun, Symantec, a whole bunch of different places, and it's certainly a fascinating time to see all of this amazing tech-fueled disruption that's happening in the world around us. So today I want to focus on what are the lessons learned from the tech giants themselves that all of us can apply in our different jobs. So first of all, there's this notion of the innovation North Star. And really it's around what we're seeing in market innovation and business disruption that's happening from the tech giants and others. And it's really special in three different ways. So the first one is velocity. You know, if you think about it, in under 5 years, Amazon went from not even being in the consumer electronics business to having sold 100 million Alexa and Echo devices. Also think about how fast they fail. You remember the Fire phone? You know, in the market for less than a year and then gone forever. Second thing interesting is about how these tech giants go after any market segment. Could be music, movies, food, you know, self-driving cars, anything is fair game, and more on that in a bit. And then the third thing that I think is really interesting is they keep leveraging their technology platform to increase the speed and deliver better experiences. So if you think about Amazon as an example, they obviously already have AWS that came out of the infrastructure for the original bookstore with compute, now with AI, with Lambda, with all these different baseline capabilities. And then when they went to launch Echo with the Alexa capability, they could build on that foundation to teach Alexa how to do conversational AI and use that for whatever comes next as well. So, you know, velocity, segment crossing, and leveraging these tech platforms really give an interesting change in innovation speed and innovation ability that the tech giants have. So what else is happening? If you look at the Fortune 500, literally over 50% of it has changed over since the year 2000. Lots of long established companies are being displaced every year. New companies are rising, some are dying, and the new companies are taking share, and they're taking it in new and different ways with better consumer value propositions, new business models, new routes to market. And, you know, another way to put it is that every year, many companies are rethinking their value proposition and how they can deliver, you know, interesting capabilities out to their customers. And so think about even in just the year 2000, while the world was going through this crazy COVID-19 outbreak, Peloton took a huge amount of share from traditional on-premise gyms. And a lot of these streaming services were taking share away from movie theaters and other places where you get face-to-face entertainment. Amazon, who is already huge, almost doubled last year. They added 400,000 jobs, and now they're well over 1 million to deal with this. Now, will some of that stuff go back to the way it was before? Sure, to some degree, but a lot of those changes will stay. And so this idea of being able to serve customers in an online way, in a digital way, bringing interesting capabilities and experiences is accelerating. And I think, you know, COVID was, you know, one way to look at it, glass half full, is it was a forcing function for many of these companies to accelerate their interesting new experiences, their ways of doing things in an online-only fashion. And that won't go back. Companies will only continue to do that more and more, so that everything that you do to interact with them as a customer, as a partner, you know, as a supplier, all the right around the company will be available more and more in an online way. And so, one of those changes from COVID that I think is certainly here to stay. So the next thing I wanted to talk about is the size and the speed. And so if you think about tech giants, companies that are both giant and fast is actually relatively new. Normally we think of big and slow companies or small and nimble. You think of the startup that maneuvers around the bureaucratic behemoth. The largest companies traditionally built and protected market share in one or two categories. Think about retail, think about banking, think about automotive, consumer packaged goods. Most of the large Fortune 500 companies traditionally in those industries stayed in that swim lane. And also as they grew and grew and grew, they typically slowed down. They got bureaucratic, process, bureaucracy, and their ability to deliver new products, new capabilities, new services over time went and gradually eroded to, a snail's pace. And so tech giants are not that way, right? Tech giants are huge and they're fast, and they're getting faster all the time. And so I think that lesson is really important. And a lot of it has to do with treating new businesses, new divisions, new capabilities, almost as startups, within the larger organization. So we talked about this tech giant innovation a little bit. Some of the people that are innovating and winning new market share are crossing the industrial and vertical boundaries. Some of them are small newcomers coming in, but a lot of them are taking share in totally different ways. If you think about Apple, for example, their phone and iPhone and that whole smartphone generation is taking market share from Nokia and BlackBerry, from Kodak cameras, from Sony Walkman, media companies, Garmin for GPS, and so on. Amazon is selling groceries, making movies and TV shows, and trying to displace traditional pharmacies now too. Google X is building self-driving cars, smart glasses, and robots for just about anything. So that's why I call it no lanes. The lanes of traditional competition are eroding. One thing in common across all of these tech giants and others aspiring is really the criticality of data. Data is the lifeblood of modern organizations. It's fueling innovation and new experiences, and it's illuminating the market. Companies are rapidly trying to adopt AI, but they're still failing at a pretty high rate at that. So one thing I noticed is with a son going to college this year that data scientist is now one of the most sought after majors available. And it's available at over 500 colleges and universities. And so, figuring out how to employ the right people, how to leverage data, how to make the most of it for new experiences, for understanding what's going on with your customers and their needs and the trends is a huge innovation stimulus that is happening across the industry. So while data is critical for innovations and success, it still remains a major challenge. Many companies have spent much of the last decade automating for speed, right? Automating their infrastructure with hypervisors and clouds, the ability to spin up and spin down a server. It's very popular. These same companies have also been automating their SDLC with the DevOps toolchain. Think about Jenkins, Puppet, Ansible, Git, all of these tools to make it easier and easier to do a build, to grab a build and run it on a server, to configure services around it and get ready to run a set of regression tests faster and faster and faster in a CI/CD toolchain. So these are speedboats, right? Speedboats zooming around, on little iterations, little tight turns, helping get the next version of code ready to go and into test and then into production. But the challenge is a lot of the data is still on big cargo ships. In many cases, it takes teams, 10 minutes to get a new server up, 10 minutes to get a new build ready, and then 5 days with DBAs and a lot of manual effort to get the 10 terabytes of data into the test environment. And so the data really remains kind of the big, slow cargo ship relative to all these speedboats in terms of a CI/CD pipeline, and it stops any notion of it being a continuous process. So think about your infrastructure and code are on speedboats. You need to put your data there too. Another big theme here is that there are continuing constraints coming from the regional regulation deluge. What do I mean by that? Well, starting with GDPR a few years ago, the EU really put on the map a notion of a comprehensive set of privacy regulations that protect citizen information. All the PII is now governed under GDPR, such as names, addresses, phone numbers, country IDs, credit card numbers, all that kind of information that can be used to determine the identity of an individual. And so following GDPR, there have been an ever-increasing set of similar regulations popping up all around the world. In the US, you have lots of state-level ones like CCPA and SHIELD, and there's new ones in Illinois and Texas and Oregon. All over, regulations kind of similar to GDPR, but not exactly the same, are popping up. And the same thing's happening with countries, whether it's, the new rules in Brazil or Italy or Spain or China. And so the challenge with all of this is to comply with these, you have to deal with strategies to anonymize the data, to protect the movement of data, to make sure it follows the rules of all of these different regulations where you're trying to do business, right? And that last point is key. You're not just subject to the regulation from your state. Your company is subject to the regulation for all of the regional environments where you want to do business. So if you have customers in 50 states, fast forward a couple of years, you will have to deal with 50 different privacy regulations, one for each state that you're doing business in. And if you're an international, multinational company, you may be dealing with hundreds of regs across the countries and regions that you're trying to operate in. So this is a huge privacy challenge where you want to both leverage the data for the innovation that we're talking about, as well as comply with these regs and reduce the risk. So let's go back to tech giant innovation velocity. What are these guys doing? What's really happening? And what can you do? What can you take advantage of that are ideas that are leverageable? So first of all, it's people, it's process, it's technology. And let's talk about the people part. So finding and recruiting the best talent, enabling continuous learning, and then really creating a culture of iteration, of continuous improvement, of learning how to fail, accepting that, failing fast and moving on and trying something new, and then collaborating across boundaries. The process part is DevOps for sure, but it's broader than that. If you think about taking an engineering mindset, think about how these tech giants are looking to eliminate waste, time waste, cost, at every turn of the wheel. And so they're tuning for speed. They're eliminating friction. They're eliminating wasted cycles. And they're eliminating anything that causes manual labor in the process to slow down and wait for a ticket of some kind to be filled by someone to, create the ability to do the next step in whatever the process is. And you think about the classic book, The Goal, which I read a long time ago now. Eliyahu Goldratt wrote about assembly lines and constraint theory. He wrote about finding the bottlenecks and eliminating them. Improving anywhere else is really a waste of time. And so the modern version of this is probably Gene Kim's book, The Phoenix Project, all about DevOps and the constraints and application projects. So the lesson really is to automate everything, to try to treat everything as code, treat infrastructure as code, treat the SDLC as code, and then to treat data as code as well. So how do you do that? Well, I want to introduce you to a concept called programmable data infrastructure. Programmable data infrastructure is a technology that allows you to treat data as code. So what are the key characteristics of that? Well, the first one is API-controlled data operations. Think about all of the data operations that you need to perform on a day-to-day basis as part of application projects, provisioning of data sets, resetting them to a point in time, rewinding back to a previous point in time, sharing with a teammate, branching, spinning down, spinning up. All of these different little data operations ought to be driven by simple APIs so that it can be connected into the process and no longer require manual intervention. Second key characteristic is any source. Be able to ingest any type of data and manage it in this way, whether it's mainframe data from the previous generations, relational data, NoSQL, new cloud data sources, running in IaaS and PaaS and even SaaS data. Operate across all of those different data sets and operate on any cloud. Third key characteristic is data compliance. You need to be able to profile the data, to find all the sensitive information, to anonymize that data, mask it automatically, and deliver it according to the rules of the regulation about where it's allowed to move, who's allowed to see it, and in what condition the data needs to be when it's delivered. Next one is version control. So the idea here is, just like you use Git for your source code, you can use a programmable data infrastructure for your data and have individual copies, check them out, if you will, do your work on that data, let it go. Everyone can be working on their own branch. Everyone can be working kind of independently, free and easy, not worrying about your dependencies between other people, which enables speed. Fifth one is immutability. And so this is really about having data captured and preserved in its original state in a time machine-like capability, so that you can go to any point in time and you know that the data that you're seeing from a quarter ago or a month ago or a minute ago is exactly in that state as it was when it was captured, so that you can do the right kind of testing, the right kind of regression, the right kind of analytics, the right capabilities for going back and doing archiving and audit, and all those types of things require data immutability. The next one, which is really critical, is data utility. And so what this means is the data needs to be delivered in the right form to enable whatever the use case is. So in the case of application development, that means that for a QA environment, you need to have production-like database data with the right size, the right scale, the right point in time, all the referential integrity preserved. You need all of the corner cases that are in the real data that you couldn't really create with synthetic data, et cetera, et cetera, et cetera. For analytics, it means that you need to preserve the features. So even though you're anonymizing the data, maybe you need zip codes to stay within a certain region so that you're not moving people from state to state. Or age needs to stay within a certain bracket so that if you're trying to do, let's say, a health analytics project and you want to look at which claims were filed from which people, you wouldn't anonymize the data and move everyone from California to New York by changing their address and moving everyone from a 10 to 20-year-old age group to a 40 to 50-year-old age group by changing their birth date too dramatically. And so preserving the data utility really is about making it, even though it's been anonymized and delivered into these other environments, still solve the point of leveraging that data in the first place. And finally, space efficiency. I talked about making, parallel individual sandbox environments available to all of the people, developers, testers, and so on throughout an application project. Well, if you're going to make hundreds and hundreds of copies, you obviously have to be very intelligent about how you use space, or you're going to blow out the storage that you have available for that project. And so programmable data infrastructure is anything that has these characteristics to enable these types of projects. And let's go a little bit more into what does it mean to be programmable in this case. So I've got a few examples to show you. So the first one is, if you want to spin up or spin down a simple data environment to use for some testing, here's a couple of lines of code in the Delphix environment that can do that. We're provisioning an Oracle database into a target server at a particular point in time, and then later we're killing it. It really is that simple. So once you attach, the platform into the data sources and connect the sources and targets, you can now have people write script-like code to do these data operations. Next one, let's say I want to replicate data from cloud to cloud. And in this case, I'm going to move a data set from an Oracle data set, in this case, from Amazon to GCP. A couple of lines of code, and you have it. Next is really about teamwork. So let's say I'm working on a project, I'm a QA person, and I found a bug. What I want to do is bookmark the data at that exact point in time where the data was set up in such a way that it tickled this bug. And then I want to share it back with the developers so they can go and triage the problem. So here you see, creating a bookmark and then sharing it out with another developer. That developer can then take that bookmark, refresh it into their environment, and that whole data set will be populated in a matter of minutes, and they can now go and, like I said, triage the error and see what happened. Finally, an anonymization case where what we want to do is run a profile job against a data set looking for PII, and then I want to start running a set of masking algorithms to anonymize that PII, name for name, address for address, and so on and so forth. So this is really what I'm trying to get at with Programmable, where you can take things that are normally hundreds of steps, lots of manual effort, and automate them in data infrastructure such that they can be seamlessly built into all of the CI/CD pipelines. All right, so to summarize, if you look at these tech giant North Stars, they've inspired companies from every industry to find ways to innovate and accelerate, to bring new products and services to market, and to engineer out everything that slows them down. Just a relentless drive for finding that next bottleneck and eliminating it, and then finding the next one and just spinning and spinning and spinning to take things from, weekly release cycles to daily release cycles to hour minute release cycles. Same thing can be true at a different scale. Maybe you're at a large enterprise company where today, large applications are coming out once a year, twice a year. Then maybe the next goal is to get them to monthly. Maybe the next goal after that is to get them to bi-weekly. The same concept. It's just continuing to shorten those cycles, which improves quality, which create new features out for the market, and you can get the feedback and iterate and move on. And so to do this, like I said, most companies can automate their infrastructure. Many have eliminated much of the dev test bottlenecks in CI/CD pipelines. And then now, with programmable data infrastructure, companies can also automate the last mile, in quotes, the data, and finally achieve full digital velocity. So thanks very much.